Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. For those challenged with promoting the use of machine learning in an organization and making it more accessible, a key to success is to support data scientists and machine learning engineers with modern processes, tools, and platforms. This is a topic we're excited to address here on the podcast with the AI Platforms podcast series that you're currently listening to, as well as a series of ebooks that we'll be publishing on the topic. The first of these ebooks takes a bottoms-up look at AI platforms and is focused on the open source Kubernetes project, which is used to deliver scalable machine learning infrastructure at places like Airbnb, Booking.com, and OpenAI. The second book in the series looks at scaling data science and ML engineering from the top down, exploring the internal platforms companies like Airbnb, Facebook, and Uber have built and what enterprises can learn from them. If these are topics that you're interested in, and especially if part of your job involves making machine learning more accessible, I'd encourage you to visit twimlai.com/AI platforms and sign up to be notified as soon as these books are published. In this episode of our AI Platform series, we're joined by Daniel Jeavons, General Manager of Data Science at Shell. In our conversation, Daniel and I explore the evolution of analytics and data science at Shell and cover a ton of interesting machine learning use cases that the company is pursuing, like well drilling and charging smart cars. A good bit of our conversation centers around IoT-related applications and issues such as inference at the edge, federated machine learning, and digital twins, all key considerations for the way they apply machine learning. We also talk about the data science process at Shell and the importance of platform technologies to Daniel's organization and the company as a whole. And we discuss some of the technologies that he and his team are excited about introducing to the company. And now, on to the show. All right, everyone, I am on the line with Daniel Jeavons. Daniel is the General Manager for Data Science at Shell. Daniel, welcome to This Week in Machine Learning and AI.
Thanks so much for having me.
Before we jump in, I'd love to hear a little bit about your background and how you got to working in data science at Shell. I know previously you were the general manager for advanced analytics at the company, and you've worked in that capacity for a while. Tell us a little bit about your background.
Yeah, so it's not a straightforward story. When I left university, I joined Accenture, as many of us did in that era, and spent a bunch of time developing big systems. And I guess the easiest way to describe what I was doing was data engineering without any of the tools. So we used a lot of SQL.
Sounds fun.
It was tough back then. We hacked a lot of stuff together in Excel and made some crazy business insight for executives based on core business processes and taking raw data out of SAP. It was a fun time. We used to spend most of the evenings extracting data and then run it overnight and come back and hope the results worked in the morning. And that worked pretty well, but it was a fun start, and I learned a lot from that. But I also got really interested in the interface between data and process, and I guess the easiest way to describe my career is that I've always been in that interface. And so then I spent a lot of time learning about things like Six Sigma and Lean and trying to apply some of those techniques into the business processes that I was extracting data for and trying to improve the way that our business ran. And I went through a whole series of roles in that sort of area, from data architecture to process architecture in the CIO office in a more strategic role. And then eventually got to the point where I saw back in about 2012 that increasingly there are a whole series of new tools coming out that were starting to apply data science in really interesting ways to improve the way that the business ran. And what I saw was that this was going to be a big thing, and it was going to change the way in which industry did business. And so I went to my manager, who was at the time Shell's lead architect, and I said to him, look, I see a big opportunity in this space. Would you let me go and start something? And he said, actually, we've just created a new role. The IT executive wants to do something as well. Why don't you apply? And so I applied for what we then called the Predictive Analytics Center of Excellence lead position. And I think they didn't really know what it was or what it was supposed to be. And so they appointed me. And I sort of went back to my roots and I said, well, what do I need to make this successful? Well, I need some good data engineers and I need some people who understand stats. And so I hired a statistician, and I went back to some of my old colleagues and brought in a data engineer, and we got started. And we didn't really know what we were doing back then. We were sort of making it up as we were going along. We got a lot of input from others and talked to a lot of different companies. But what was really interesting was we figured out pretty early on that the way this works is you focus on the value and actually getting good at articulating where the value is from a business use case is really fundamental. And what we did was we effectively built out some cases around the customer space. We also focused on some work in our finance space and some work in the asset space. And all three of those paid pretty modest dividends pretty quickly. And that gave us a bit of a mandate and a bit of momentum to start to grow. And I think maybe skipping forward a little bit, we went through a couple of years of sort of modest growth. But where it really changed was we hit on something that really resonated. And we ran our first big project, which was focused on spare part inventory optimization. And we were able to deploy that quite quickly as a minimum viable product, and it suddenly started to make millions of dollars. And it was at that point that the game shifted, and suddenly this became a big thing, and it became very much on the agenda of the executives, and they got very interested in what we could do. And from there, really, the team's been growing very, very rapidly. And I've been through various incarnations of positions, as you mentioned, to my current position, where I'm now running about a team of about 130 people worldwide, based in 4 global locations, combination of data scientists and data engineers. And we're running use cases right across the business.
Interesting. I'm really looking forward to digging into some of those use cases. I did want to ask, though, seeing this transition from advanced analytics COE to data science COE, tell me about the kind of background behind that change. Is it more significant than rebranding the role and the mission, or does it have a significant meaning to the way you do business?
Well, I think if you go back to the beginning, we had the idea really of putting statistical methods into software applications and deploying them to end users. That was, if you like, the initial mission that we came up with. But I think we always saw how this could evolve, because even we're talking back in 2013 now, we could see the early writing on the wall around the development of machine learning and also things like natural language processing and AI and the way in which this could evolve. And so we had that in mind, but we were focused very much on the simpler things and trying to deliver value with what we were building out then. I think it's been a pretty natural evolution, but of course, as you evolve, you need to describe what you do a bit better. And where it started off with, as I said, deploying those statistical methods, we're now deploying advanced machine learning at scale. And so we need a title that reflects that. So I think it's not that the mission or the vision has changed, but just we've managed to follow the roadmap and hence needed to rebrand.
One of the things that you mentioned in your background is this. Actually, there are a couple of things that I wanted to probe into. One is around this idea of kind of the interface between process and data and analytics, and how you apply these techniques at that interface. But you also mentioned really needing to understand the value that these types of projects can bring to the table. Starting with that, what have you learned about kind of capturing the essence of the value proposition of these kinds of projects?
So I think there's a couple of things I would say. So just linking to that process and data point, I find that people tend to look at the world through one or other lens. So business folks often tend to look at it through the lens of the process and forget about the data. And data practitioners often come at it from the data side and forget about the process. And the answer is you've got to understand both to really be successful. If I talk about that inventory use case, which I talked about as our big sort of launching case, the key there was that interface of process and data. So what we understood was the data allowed us to develop certain recommendations around the stock levels that we were operating. And off the back of that, we could improve statistically the recommendations we were giving to the industry analyst. And that was relatively straightforward. But what we then had to do was work really closely with the experts in the business through, in this case, the Materials Management Center of Excellence internally. So the team that looked after materials management as a discipline, and try and work with them to say, how are we going to fit a tool into your business process? And the reason it was successful was because we made a tool which made it really, really easy for the inventory analyst to do their job. And ultimately, that's why it was so successful. So I think that's one element of how you get to the value. I think the other element of getting to the value is understanding the friction. So again, if I use this as an example, what we understood was the inventory analyst could probably get to the same recommendations that the algorithm was making or close to, but it would take them several weeks. And that's not scalable, and it's not even doable, because what that means is it doesn't get done. So what we quickly figured out was that actually understanding that friction point, which was this saves the inventory analyst time, was key to getting the value of which also leads to better decision making, and off the back of that, bottom line impact. So it's that friction understanding that's been really key to our journey. I think the other thing is, and maybe one of the other big learnings, and learned from some of my failures here as well, often the business will ask questions which are thinly veiled, I have lots of data looking for a problems. And that's the worst type of definition, because ultimately more data is not better. What's better is to have better insight, and that typically means small data. And so the challenge of any analytics project is taking big data into small insights, which allows someone to make a better decision.
You mentioned that better insights typically mean small data. Can you elaborate on that? I think that is counterintuitive to the way we think about a lot of these problems nowadays.
Yeah, I think so. I mean, it's not saying that you don't use a lot of data in coming to the insights, but ultimately, if you look at, let's take an operator in the North Sea, for example, we're currently asking them to deal with probably 10,000 data points on any given day. So they should be looking at the incoming variables from 10,000 different sensor feeds about their plant. No one can process that amount of data. And ultimately, you end up with just information overload, which means you shut down or you switch off or you manage on intuition or gut feel. Mm-hmm. And the challenge of data science is, can I take all of that incoming data that I have and turn it into the three things that operator needs to look at, and make sure that they really pay attention to those three things, because that's what we're comfortable with dealing with as human beings. So a lot of my team and the thinking that we try and instill in people is, look, you've got to make it easy for your user. We like our iPhones because the app is typically only giving you one or two or three pieces of information. That's what a well-designed app does. And you might deal with a lot of apps in a day, but actually each one is pretty targeted in the way that it surfaces information to you. And that's really the same sort of thinking we try and bring into the design of the things that we build for our business users.
So I recently had an opportunity to hear one of your colleagues talk a little bit about the various use cases of machine learning at Shell at a conference. And I'd love for you to kind of run through that list. I mean, you've got a ton of things going on in this space. Can you give us a taste?
Yeah, of course. So we're looking at the application of machine learning into areas in the subsurface, for example, like well drilling, where we're trying to automate the way in which we do geosteering using machine learning. We're also doing work in production, looking at predictive maintenance. So in other words, how can we predict failure on pieces of equipment? That's everything from valves to compressors to heat exchangers. And going back to the example I gave on the operator, trying to give our operators really meaningful insight around the areas they need to focus on. We're also looking at optimization of those assets. So how can we use machine learning and other techniques to optimize the throughput of our manufacturing equipment, our production equipment? We're working with trading in a number of areas, trying to improve the way in which we manage our trading portfolios, the way we manage risk, the way in which we also make bets and take positions in the market. We are looking at optimizing our lubricants and the way that we blend our lubricants, effectively trying to leverage larger data sets to understand how we can make our products more effectively or more efficiently. We're working in retail, trying to develop new insights for our customers, but also trying to make our sites safer by using things like machine vision. And actually, machine vision is an area that we're looking at far more broadly, because leveraging video footage across our very physical value chain is a huge opportunity. And then we're also working in the new energy space, where we're starting to try to develop algorithms to charge cars more smartly, and also save our customers money in the process. So that's just a few examples. I could go on for a long time.
How does your organization support such a broad portfolio of application areas? Are you kind of embedded into the different business units or business processes, or do you operate in a more centralized way?
So I think it's a combination. So the way I describe my team is we try and provide a technical backbone to these projects to make sure that we do them consistently. We operate with common standards, and we deploy them to a high level of delivery. So we're trying to act as a true center of excellence, if you will. We're often bringing in resources, I would say almost always bringing in resources from other parts of the organization. We partner very closely with our business service centers because they have some great data scientists there. We also partner closely with our IT colleagues because we need them to help us operationalize the things that we're building. And of course, we want business people embedded in these projects, because a lot of this doesn't work unless you're very close to the user and the person with the problem who really understands the case that you're trying to develop. So our most successful stories are those where all of those ingredients are there. So I think it's the best way to describe it is we're involved in a lot of these projects. We're providing technical assurance, expertise. We're hands-on in terms of the delivery, but we're not doing it on our own. We bring together cross-disciplinary working teams to deploy the outcome.
You mentioned operationalization as well as technical standards. To what degree have you established a standard set of tools, practices, or a concrete platform upon which you build these types of projects?
That's a great question. So I think I'll answer that in two ways. We certainly have established tools and best practices. So I talk about my Center of Excellence as having three core functions. Number one, we develop the underlying platform. We work with our IT colleagues to do that. The second thing is that we develop a series of use cases on top of that platform to demonstrate the value of it. But we also democratize that platform to allow others to use the platform as well. And we run a network to share best practice with about 2,000 people across Shell around how we do this. So that's the operating model, if you will. If you talk about the platform specifically, it's always evolving. So we built the first platform in about 2014, early 2015, I guess. And of course, the technology now has moved on significantly since then. And so we're in the process of working through some of that and refreshing some of our tools and our ways of working. But we've had a number of core components that have been very successful and will be with us for a long time to come. Things like Alteryx and Databricks, have been the standards, as well as R and Python. And we've done a lot of work in those tools. Increasingly, though, we're also looking at others, things like C3 IoT. We do a lot of work with MathWorks as well. So it's very much, we've brought together a best of breed tool set. And of course, we're really excited, as you may have heard, around Microsoft and working very closely with Microsoft now to move things into more of a PaaS setup in the public cloud. And so that's very much the direction that we're heading in.
And a lot of the use cases that you support are, what we've come to start calling edge applications. So can you talk a little bit about how the IoT and edge use cases impact the requirements that you have on the underlying platform?
Yeah, of course. So I think a couple of things. I think in the strictest sense, Shell has been an IoT player for a very, very long time. And we've had a consolidated sensor infrastructure for many years. It's based on a technology called OSI soft Pi, and we effectively aggregate all of our sensor data into centralized repositories. And that's been a huge enabler for us because, of course, that means you don't have to deploy all the sensors and you don't have to deal with some of the IoT problems. We just pick up the brilliant work that others have done to aggregate all that data for us. So that's been a big play. And the challenge there has been making that available in the cloud and starting to leverage machine learning on top of that. And that's been a really exciting journey. But increasingly, as we deploy new solutions, we also need to deploy things to the edge, and in particular, deploying machine learning. So the best example is some of the work we've been doing in retail recently, where we're now deploying cameras into retail sites in Singapore and in Thailand. And into those cameras, we actually, because we've got 6 cameras generating about 200 megabytes per second in data volumes, we need to be able to filter that before we pass it into the cloud, because otherwise it just becomes unmanageable. So what we're doing is we're using effectively edge deployment, and we're allowing the containerized cloud-based environment to push machine learning to the edge to act as a filter to allow us to only retrieve the elements that we need into the cloud for type processing in a scaled environment like Spark. So that's pretty cutting edge, and that's pretty exciting, and that's one of the areas that I'm really enjoying working in. The other example, of course, is some of the new devices that are coming online. So things like charge posts. So we're doing a lot of work around how can we deploy algorithms which have full connectivity into charging posts so we can optimize the way in which we provide electricity to electric vehicles.
The retail application you mentioned was one that was highlighted at the Ignite conference. Can you talk about that in more detail? What are its goals?
Of course. So, I mean, our retail business is huge. We're the largest single branded retailer in the world. We operate in about 70 different markets. We have about 44,000 sites, and we deal with about 30 million customers every day. That's an incredible scale. And of course, in that business, we want to make sure that our customers are safe and secure and that we protect them from risks. And as you will know, I mean, having hydrocarbons there has an element of risk to it. And so we need to make sure that we're able to intervene in situations like smoking, which is remarkably still an occurrence on some of these sites, as well as looking at other risks like people speeding or going in the wrong direction, which may have an impact on pedestrians going into the store, or situations where we may have robberies, heaven forbid. We want to be able to make sure we can detect and ideally detect the symptoms of those things about to happen so we can make an intervention. And so what we've done is we've developed a machine learning system that's looking for some of those well-known symptoms that are about to cause issues, and then providing those as alerts back to the service champion. So that's the person who looks after the customer in the store. And we're currently in a pilot phase with that. We're testing it out in Singapore and in Thailand, as I mentioned. It's going pretty well. It's early days, but it's a really exciting area for us because there's so many use cases we can think of that can help improve our retail business, but way beyond that into our production business and into our refining business and elsewhere. Because at the end of the day, what we've built is a standard platform that runs in the public cloud that allows us to operate all of these cases at scale on a common infrastructure.
And so this particular application, as you mentioned, is based on capturing video. You mentioned that the video that's being pushed to the centralized processing in the cloud is reduced bandwidth. Are you also doing inference at the edge, or are you tell us a little bit more about how that's what's happening there?
Yeah, of course. So, I mean, if you think about it, what we have is about 6 different cameras that are all pushing footage into an edge device. We've then deployed a thin machine learning model, so a thin deep neural network, if you will, to that edge device based on TensorFlow. But it's kind of a YOLO type model. What it's doing is fast and loose inference, pulling out frames of interest and passing those frames into the cloud. We're then loading them into a blob store environment, but then automatically bring them up into the memory of the Spark cluster. And the Spark cluster is then using effectively a Kafka stream, passing those through and identifying potentially interesting events that we want to notify the service champion about. Those events are then pushed into a database, which provides an alert back then to the service champion in a dashboard which runs on an iPad. So that's a very brief overview of the architecture, but the core elements are inference at the edge and tighter inference in the cloud to reduce false positives, and then Kafka acting as the bus to pass those alerts through into to the service champion in the form of a mobile device.
And so the inference that's happening in the cloud is based on a more robust model, presumably?
Yeah, it's deeper, of course, because what we've got is a smaller data volume, and you can do tighter inference. So you're using effectively deeper neural nets to make more robust recommendations back to the service champion.
And are you in any way federating the training or the models, pushing the knowledge in the centralized models out to the edge periodically, or training them in concert with one another? Are you doing anything in that space?
So we're continually retraining based on new data and feedback from the service champion, because both of those two things are important in refining the models. We're also working with offline training data to also try new things to try and improve the models as well, and new ideas based on the new footage that we now have. I think I'm sure you'll hear this from a lot of people, but training machine learning is obviously, it's a bit of trial and error. You've got to try a bunch of things and iterate quickly. And that's very much the phase that we're in now, to try and make our models more robust. The beauty is that we have these things fully containerized, though. And as they improve, we can pass those down to the edge to improve the way in which they perform.
On that note, how do you do experiment management?
Well, it's a great question. It's a tough one. Maybe the best way to describe it is what we're trying to do across the department. I mean, of course, we have design of experiments training that we roll out for a lot of our data scientists. I think the other thing is that we have a setup around quality where we put in place a bunch of peer reviews to try to make sure that we're doing things in a sensible way across the team. I think, though, as well, and this is maybe a bit of a non-answer, that the challenge with this is some of this is quite new for us. And so in some ways, as I said, it's a bit of trial and error as to what works, particularly given the architecture that we're using is quite new. So we're trying to learn a lot from the way that others are handling this. We're learning a lot from other organizations who are perhaps ahead of us, some of the tech giants, for example. But I think it would be unfair to say we've got this right. We're still very much learning.
Another thing I'm curious about is the degree to which you've instilled formalized processes around screening for bias in data sets or results. For example, in this application that's very much consumer facing and based on video, which is, we've seen recent examples of bias creeping into the use of object detection, image detection, facial recognition, things like that. How mature would you say your data science practices are in terms of understanding and building processes in place to protect against that kind of bias? And where do you see that going?
Yeah, it's again a really good question. I'll answer that in two ways. I think we've merged in my group, the statistics group and the data science group. And I think that has really helped in the way we think about quality of models. Because as you can probably appreciate, the statistics group have a much deeper understanding, if you will, of the potential for bias to cause issues. So we've had a stats group since the 1970s. It's a very mature group. And I think they've really helped in terms of bringing the challenge into some of the data scientists who are perhaps more focused on some of the more emerging technologies and have a deeper knowledge there. So I think it's that cross-pollination between different disciplines that's helping us in the way that we develop these models. And we're trying to encourage that across the team. And in particular, I mentioned the quality initiative that we're starting to roll out. We're trying to make sure that we have peer reviews to look at this and look at things like systematic bias in the way that we're developing our models. I think the other thing that's really important that we're talking a lot about at the moment is estimating uncertainty and distribution at the source of the data sets that are coming in, and really trying to understand that so you're not building in systematic bias through basing your models on a small set of observations. And I think in particular, one area that I think has a lot of promise here is using synthetic data to train the algorithms. We're not there yet with that, but I think that's an area that we're really interested in because we think it has strong potential to remove some of those biases.
Is there a particular use case that for which you see that as being most promising?
Well, I think it's more a category. I mean, it's very early days with this, right? And we really don't know if this is going to work, by the way, because the question is, can you accurately generate enough realistic data to be representative? I think what we're excited about is if you look at the occasional event from a machine vision perspective, it's very hard to get a representative set of footage around that, right? So you can end up very easily overfitting. Whereas I think what's quite interesting is if you think about synthetic data, you can potentially generate a vast quantity of data in a VR world that gives a real indication of potentially all the scenarios in which this could be observed, and creates a much more representative data set to do a first pass training on your model. Now, we still don't think that synthetic data will take us to real world in one step. It's going to be a two-step process. But if we can build that into the way we think about machine vision, it could be a real game changer, we think. But like I said, I can be wrong on this one.
Yeah, no, I think you're right. I agree. I wonder what the time frame is for all of the pieces to come together. There's been some interesting results in combining synthetic data with real world data and applying techniques like domain transfer. But a lot of that stuff is really bleeding edge. And I'd love to hear if there are any, tools or papers or things like that are top of mind for you in having looked at this.
Yeah, I mean, like I said, we're at really early stages, and a lot of this we're kind of going it alone because we haven't found anything that's bang on point yet. Not for the use cases that we're interested in, and so I think this is actually an area where we think we might be able to publish some useful material that's going to drive some of the discussion in this space. So watch this space is what I would say.
So we talked a little bit about the experiment management side of things. How do you approach model management and deploying models out to production and managing their performance over time? What kind of tooling have you built up around that and processes?
That is a great question as well. So this is a real headache. So let me just be completely honest with you on this one, right? Look, I can answer it with a simple answer, which is, we containerize our models. We use things like Azure Container Services and Kubernetes to deploy them. We embed metrics so we can manage it. We're doing some work looking at things like ML flow in Spark to help with some of this. However, I'll be completely honest and say we're working with C3 IoT to try and crack this problem. And I'll explain the scenario that we're working through. We have thousands of valves across our business. Literally thousands of them. And we want to be able to run machine learning models for every single valve. Now, every single valve is slightly different. The flow is different. The temperature, the pressure is different, right? So you basically need a model per valve, but you don't want to manually manage that because it's just unmanageable. So you need drift management. You need the ability to automatically transfer between different types of models. You need human override on those valves to actually replace the model with one that you think is going to perform better. You need to be able to retrain those models on a regular basis based on new incoming data sets. And you need methods to actually manage the overall performance of the system in a simple way that gives an end user the ability to look across the entire set of valves. So to give you an idea, on a refinery, you might have 10,000 of these things. So that is it's a real world problem. It's a great real world problem. It's a really exciting one, but it's also a real challenge. And so, like I said, we've gone and we've worked with C3 IoT to look at can we leverage their platform and their type system to help us to manage that level of machine learning deployed into an asset where we have to be able to support a user interacting with that every day.
Right. Adding the edge components to the model management challenge makes it a lot more complex. Relative to serving up models to some centralized website or via centralized website, I can definitely see where the complexity comes in there. You mentioned the valves and building individual models for these valves. I'm assuming that's kind of this digital twin type of use case. How do you end up using those digital twins? And do you like that terminology? Do you use that internally or not really?
Yeah, we do. I think the problem with the terminology is that everyone means something different by it. and it's everything from a simulated set of the physics of the operations of the system through to a 3D model based on CAD drawings and all the variations in between. So you have to be a bit careful with it. And we're trying to standardize on a definition internally so that we can say this is what we mean, and then it has these attributes. That's the current discussion that we're going through. So interested if anyone else has had a similar problem. But what we're trying to do really here is it is kind of a digital twin setup. We're taking a hierarchy of the equipment that we have on the site, and then we're effectively tagging the things we want to monitor with a model against that hierarchy. And then we're able to manage that basis the way in which the asset is set up. But it tends to be specific pieces of equipment. And of course, within the context of that, we're taking the historic data feeds about that piece of the asset, and then we're running an algorithm, typically a machine learning model, not always a deep learning model, by the way, against that particular piece of equipment in order to provide results back to the user.
Do you ultimately end up with, for a complex piece of equipment, as you're trying to make predictions against the performance of that complex piece of equipment, an ensemble of thousands or tens of thousands of submodels representing the individual parts? And have you built a framework that allows you to do that kind of thing repeatedly, or are we not there yet?
Well, so what's really interesting is actually we're going the other way right now.
Really?
So one of the things that we found is that the difference in performance between the submodels that we're building out, in the complex system versus basically having a master model that cuts across all the pieces of equipment is not differentiating. And of course, having the master model is much easier. So we're currently playing around with that, but we actually think that more and more we'll be moving towards master models for certain things. But to be honest, it depends, because it's not a one size fits all. For certain pieces of equipment, we found having one model monitoring a whole sort of train, if you will, works really well. And for other things, you've really got to monitor that piece of equipment using a very specific model. So I think I would say we're learning all the time with this, because we're sort of looking at it. We're learning as we go, and it's something we believe quite passionately in, right? Which is you go through a process and you iterate on that, and you don't overthink it, and you may try 3-4 different approaches even within the same team. And that's okay, because I don't think anyone's done this, not at the scale that we're trying to do it now.
Shell was actually featured pretty prominently at this conference we keep referring to, the Microsoft Ignite conference, in the Satya's keynotes. And one of the examples was the use of not just the work with C3 IoT, but their recent acquisition of Bonsai and some of the work you're doing around reinforcement learning and the application of that. That's also, like all of the things we've talked about, very new. But can you talk a little bit about that work and what you've seen there?
Well, yeah, absolutely. I mean, what this came out of was basically the idea of the self-driving car. And the idea was basically, well, if they're making self-driving cars, why can't we have self-driving wells, basically? Because if you think about it, in some ways, it's a simpler problem to solve. There's less dimensionality to it. There's less uncertainty to it in some ways. There's less unexpected events, though you still have them. And so effectively what we've been trying to do is develop, based on a three-dimensional model of the subsurface, a set of automated geosteering algorithms that allow us to move the drill bit through the subsurface in line with the well plan. And that's the simplest way to describe it. Now, if you think about that, it's actually a very, very suitable problem for reinforcement learning, because it's got a very simple penalty function, right? Out of well plan, you assign a penalty, and off the back of that, you can very, very quickly start to bring the well back into line as you train the algorithm over time. And what we found was that the Bonsai solution effectively gave us the opportunity to do that very easily at scale. And we could, it's one of those things, you can do this yourself, but actually if someone's built a framework for doing this at scale, it's going to be much easier for us to do that as we go forwards, rather than having to maintain our own software. And that was something that was very appealing about Bonsai. That's why we started working with them. And so, we're now looking at them to help us to scale this as we look at, applying it into different scenarios across our business.
So in formulating this self-driving well problem, what are the different control variables? I imagine there are tons, but what are the kinds of things that we're talking about, like rotational speed of the drill bits and that kind of thing?
Yeah, exactly. And sort of the geospatial positioning, the azimuth, etc. Right? You've got a whole series of different measurements that you're taking all the time. And the best way to describe it, right, is it's like driving forward, but you're only getting the data in retrospect. And that's the challenge with it, because what happens, of course, is the data comes off the bit and you get it kind of a foot behind where you are, if you see what I'm saying. Mm-hmm. And so that's quite an interesting dilemma in the whole process. But certainly it's looking at a multi-dimensional, three-dimensional problem set based on your understanding of the subsurface continually and constantly iterating and adjusting, as well as trying to really look at the optimum way of doing it, because it's not always intuitive. Because obviously this is directional drilling. It's not only sort of linear drilling. So your speed also changes depending on the way in which you're drilling, and obviously that has knock-on effect from an optimization perspective.
Mm-hmm. And so with reinforcement learning in general, Bonsai in particular, the notion of using simulation is key. Did you already have a simulation of this in place? And were you able to easily use that with reinforcement learning?
So the beauty of this is we have a lot of internal simulations set up for this, of course, mm-hmm. because more or less everything that we do here has been looked at and has been simulated in the past for optimization purposes. So if you take something like rate of penetration, we have endless simulations of the way in which that can be optimized. And so we can bring some of those things into something like Bonsai by having that very good understanding of the first principles simulators that we've developed over many years, as well as, of course, simulators of the subsurface, which is another element of the simulation. So I think that's been the real benefit, and it's the bringing together of our existing scientific knowledge with the new technology of reinforcement learning that's really driving this change.
Well, Dan, we covered a ton of ground here. I appreciate you taking the time to chat with us. Any kind of final thoughts or words of wisdom to folks that are, maybe at an enterprise that doesn't quite have as much experience with this intersection of data and process as you and Shell? What should they be thinking about?
I think it always comes back to really understanding your business problem. I mean, I know I talked about that earlier on in the call, but the thing I'd encourage you is that, I talked about a lot of sophisticated techniques. I talked about machine vision. I talked about reinforcement learning. A lot of the biggest value things we've done are actually the simplest things. And so, if you're feeling, like you're just getting started with this, and I know a number of companies are, actually the biggest thing is understanding where the big value is for your business and trying to solve the problem in the simplest way you possibly can. I've got a lot of time for deep science. I absolutely love it. As you can probably tell, I love some of the things we're doing, but I do think there's so much low hanging fruit in this space that getting started. And also, I would say there's some great tools out there that make it very accessible to get stuck in very, very quickly. So we've had a great relationship with Alteryx over many years, and we've had huge value from them just because it makes it so easy for citizen data scientists in the business to get stuck in and start to add value. And I think a lot of this is about a cultural change. Trying to drive cultural change across an organization where data and data science is central to the way that we do business. That's something which is exciting. It's essential for any company, I believe, but it's also more and more accessible with the latest advances in technology.
Yeah, we didn't get into the cultural side of this, but your colleague Yuri spent a lot of time talking about that in a session that I had with him at Ignite. Clearly something that's very central to the way you think about scaling data science and machine learning at Shell.
Yeah, it's massive. I mean, I think the biggest problem of this is adoption and belief, and adoption in the sense that how do you persuade people to use the output of a data science project? And the second is, do you believe that this is going to improve the way in which you do your work and make your life easier? And I think it also comes down to, we've got to learn as an organization to work in a way that's more familiar to software houses. So things like, developing minimum viable products, having strong product ownership, iterating quickly, failing fast, being able to pivot, having the setup in which you are willing to work with a minimum viable product, not tell the people that developed it that it's rubbish. Those sorts of things are not commonplace and not comfortable for an organization like ours. And so it's as much a challenge of building an understanding on both sides, building an understanding on the business side of the way in which we need to work, and building an understanding from the way that we're working with the challenges that the business people have every day, and bringing those two worlds more closely together. And it's an exciting challenge, but it's one that's going to take time, and it's core to how we're trying to get the value out of what we're doing.
Fantastic. Well, Daniel, thank you so much.
Thank you.
All right, everyone, that's our show for today. For more information on Daniel or any of the topics covered in today's show, visit twimlai.com/talk/202. To learn more about our AI Platforms series or to download our ebooks, visit twimlai.com/AI Platforms. As always, thanks so much for listening, and catch you next time.